So communication matrices are again a type of binary matrix. So they represent a communication system. So who can talk to who can communicate to who. All right, so the ones represent links in the communication system. Who can communicate with who? Okay, so direct communication between two people is called one-step communication link. Okay, so one-step communication link. So this is shown with a 1. So direct communication, you can imagine, between two people. That's, one person there, and they can talk directly to each other. So you're standing in the yard talking to somebody else. That's that direct communication. So if communication between two people can only occur with the help of a third person. So, an example of that is if you need an interpreter to communicate between the two of you, or, if two people are in the fight and they can't talk to each other, they need a third person to talk to. So this is called a two-step communication link. Okay. So, this might be person A, this might be person B. They can't actually talk directly to each other. They need person C there. Both of them can talk to person C, and person C can talk back to them, but they can't directly talk to each other. And those circumstances where we need an interpreter is an ideal situation, an ideal example of what's happening here. So we can find a matrix that identifies this two-step communication by squaring that original matrix C, so C squared. So in the same two-step communication, if the sender and receiver are the same person, it is called a redundant communication link. So the non-zero elements on a leading diagonal. Okay, we'll see some examples of this and it will make a bit more sense. So the total number of communication links can be found by adding one-step and two-step communication link matrices. So that's a good thing to make sure that that's your total number of communication links. Okay. Okay. So I've taken this from the book because it says it rather nicely. It's a good little summary. So communication matrix is a square binary matrix in which the ones are used to identify the direct or one-step links in your communication system. So when we square that communication matrix is when we can see the two-step links, okay, and how many two-step links there are. So the total number of one and two-step links can be found by adding those two matrices together. So we can also determine like 3 or more step links by looking at the 3 cubed and c to the power of 4, but yeah, that's sort of going a bit beyond what we're doing further maths. So looking at this example, we've got that Alan can talk to Chris. You can see Alan can talk to Chris, but Chris can't talk to Alan. How do I know that? Because there's no arrow. Okay, the arrows tend to show who can talk to whom. Okay, but Chris cannot talk to Alan. We can represent this diagram as a matrix. So looking at this diagram, you can see Alan and Brittany can talk to each other. Brittany and Chris can talk to each other. Danny can talk to Brittany, Alan can talk to Chris, and Alan and Danny can talk to each other, but Brittany can't talk to Danny. It might be that Brittany doesn't have Danny's phone number. And Alan can talk to Chris, but Chris can't talk to Alan. Again, might not have their phone number, and there's no communication method directly between Danny and Chris. So we've represented this in a matrix. Okay, so we've got that leading diagonal there. So Alan can talk to Brittany, Alan can talk to Chris, and Alan can talk to Danny. Okay, Brittany can talk to Alan. Yeah, we don't put in that Brittany can talk to Brittany. Brittany can talk to Chris, but Brittany can't talk to Danny. That's why we've got a 0 there. Chris can't talk to Alan. Chris can talk to Brittany, but Chris can't talk, doesn't talk to Chris, and Chris can't talk to Danny. And Danny can only talk to Brittany. Have I got a mistake there? Okay, this shows the one-step communication link. Okay, so this is that to the power of 2, so it's squared. So C squared shows the total, shows the two-step communication links, and adding the two together shows the total number of 1 and 2-step links. Okay, let's do an example from an exam. And this is 2017 exam 1. So question 2, meaning, it's early on, so it should be fairly straightforward. Now, I remember this being not well done by our school, and we think some of that issue is because there's a lot of, words here. Okay, so you've got to be able to read all of this information and understand it. So the matrix below shows how 5 people, Alan, Bevan, Charlie, Drew, and Esther, can communicate with each other. So you can see that Alan can talk to Bevan and can talk to Drew. Okay, Bevan can talk to Alan, but no one else. Charlie can talk to Drew and can talk to Esther. Drew can talk to Alan and can talk to Charlie. And Esther can talk to Charlie. So, a 1 in the matrix shows that the person named in that row can send a message directly to the person named in that column. For example, the 1 in row 3 and column 4 shows that Charlie can send a message directly to Drew. Esther wants to send a message to Bevan. Which one of the following shows the order of people through which the message is sent? Okay, so Esther needs to send a message to Bevan. Now, Esther can only send a message to Charlie, can't she? Okay, so we know it can't be that. So Esther must send her message through to Charlie. Okay, now who can Charlie send a message through to? Okay, Charlie can talk to either Drew or Esther. Now he's not going to send it back to Esther. He's going to send it to Drew, isn't he? So let's get rid of that one and that one. Okay, because, Charlie can't talk to Bevan either. Okay, so now the message is with Drew. He can only talk to Alan or Charlie. And he's not going to send it back to Charlie, so he's going to send it to Alan. Okay, and just to finish it off, now that Alan's got it, Alan can send it to Bevan. Now that message had to get to Alan somehow because he's the only one who can talk to Bevan there. Okay, so that was E. So that 90% of the state got that one correct. Okay, so this is from 2016, exam 2. This was question 2. So the travel company has 5 employees: Amara, Ben, Cheng, Dana, and Elka. The company allows each employee to send a direct message to another employee only as shown in the communication matrix G below. So we've got G, our sender and receiver. The matrix G square is also shown. Okay. So you can see here, they've also, as part of this information, the one in row E, column D of matrix G indicates that Elka can send a direct message to Dana. Let's just go through that again. So in row E, column D, Elka can send a message to Dana. Okay, Dana can send a message to, what's their names? Ben and to Elka. Chen can send a message to Amara, Ben, and Dana. Ben can send a message to Amara and Chen, while Amara can send a message to Ben, Cheng, Dana, and Elka. Okay, now these are the 2 steps. Okay. So, to whom can Dana send a direct message? Who can Dana send a direct message to? It's to Ben and Elka. Okay, 89% of the state got that mark. Cheng needs to send a message to Elka but cannot do so directly. Write down the names of the employees who can send the message from Cheng directly to Elka. Directly to Elka. Okay. So, well, who can talk to Elka? Amara and Dana are the ones who can talk to Elka. So, yeah, that's it. Amara and Dana. And 71% of the state got that mark. Okay, so spend a bit of time working through that with your textbook questions, and we'll do some more examples also.